Bismillah ar-Rahman ar-Rahim. Let's start off where we left last time. So we were discussing the rules for rounding off numbers. So these are the fairly obvious rules that anytime we want to round off a number and the next number is less than 5, so then we just ignore everything that is after that number. So for example, we want to round off 2.5349 to 3 significant figures. So this is the first significant figure, this is the second significant figure, and this is the third significant figure, and I can just ignore anything which is written after these numbers. On the other hand, if the next number is bigger than 5, then I just add 1 to this number. So 2.53 would be changed to 2.54. The real issue is when we have 5 at the end. So if we have 5 at the end and we have an even number before, then we leave it as it is. If we have 5 1, we still round it off to 4. If we have 5 0 as the next two numbers, then if it is even, we leave it as it is. If it is odd, we add 1. So let's look at an example. So that let's look at the example. So let's assume we have a number which is n equals 1.000459. So this is a number, so I want to round off to, let's see, we want to round it off to 5 sig fig. Sig fig is the abbreviation very commonly used for significant figures. So I want to round this number to 5 significant figures. So this is the first significant figure, second significant figure, third, fourth, and that's the fifth significant figure. And I look at the next number, that is 5, and I have 5 1. So this I would, because this is bigger than 5 0, then I would add another number to the last number, which is 4. So I get n equals 1.0005. okay, so I hope this is clear, this methodology of rounding of numbers. This is the rule which is very commonly used, and this is the rule that we would use for this course. So let's move on. So only round off at the end of the calculation, not in the middle. This is also a very important rule to remember, that we do not want to round off numbers before the end result. Okay, so we only perform rounding off at the end of the calculation. In the middle, we keep on all the decimal places that our calculator shows us, and we do not round them off in the middle. Okay. So for this course we would be using SI units. So these are the most popular units used in Pakistan and most of the countries in the world. So for the mass we have kilogram, for length we have meter, for time we have second, for force we have 1 Newton, and 1 Newton is equal to 1 kilogram meters per second squared. And similarly we have pressure. For pressure we have pascals, which is just 1 Newton per meter squared, which is 1 kilogram per meter per second squared. You might have already learned of all of them in your high school, in your college. And energy, the unit of energy is joules, and the unit of power is watts. So these are the units, and for this course the acceleration due to gravity is 10 meters per second squared. So in some problems and some examples during the course, we would use some other units. For example, let me just say that the most common unit is still for meters we have meters, but sometimes we also use feet or yard. So anytime I would be using any of these units, I would tell you how to convert feet into meters and how to convert yards into meters. And similarly for kilogram, there is the other unit which is called Pascal, pounds, and this is also abbreviated as LB. Okay, there is no other popular unit for second. And for force also there is a unit which is pounds. So 1 pound of force basically means the weight of 1 pound object. Okay, we'll discuss that more in detail because we won't be discussing pressure too much. So the other unit of pressure, which is called PSI, we won't be using it very often, but these 3 units you should also be very comfortable with all of these units. Okay, so next we have to understand that during the numerical calculations, anytime we add 2 quantities, those 2 quantities should have the same dimensions. So you cannot add apples to oranges. So for example, if you want to add a length, you can only add a length to a length. You cannot add a length to time, or you cannot add length to force. So for example, this is a very popular equation. This is the first equation of motion. D is equal to d naught plus v naught t plus half at squared. So because d has the units of length, so all the quantities in this equation, all the terms which are being added, so for example this term and this term and this term, all of them should have the same units as length. So for example, this has the units of length, this again v has the units of length over time, and t has the units of time, so they cancel out and you have the units of length. Again, half is this half is dimensionless. A has the units of length over time squared, and t squared it has the units of t squared, and again you get length. So all of the terms in this equation should have the same dimensions. So this is a very important check, that if you do not remember any equation, so you have to make sure that the dimensions of those equations add up. Again, you might have heard and used this technique a lot of times in your previous courses already. So let's move on. So the best way to solve the problems is to convert everything. So what we want to do is we want to convert everything to SI units and then perform all of our calculations. Okay, so if some quantity is given in feet or inches, or a volume is given in gallons or cups or milliliters, we want to convert all of them to the SI units for our calculation. This is the most easy way to solve them, but this is not the only way. So the only fixed rule is that you keep track on whatever you are doing. Okay, so if you are looking at seconds, do not confuse them with hours and do not confuse them with minutes. You have to remember that you are dealing with seconds. Similarly, if you are dealing with, for example, kilometers, you have to be mindful that you are dealing with kilometers and not meters for the whole of the calculation. Okay, so let's look at some examples of unit conversion. So this is a fairly simple example. So the question is, how many centiliters are in 85,500 milliliters? So the quantity we are given, so we are told that, let's start here somewhere. Okay, let's go back and start. So we have the quantity we are given is 1500. So we are told that this is milliliters. So first of all, this is a unit of volume. So first we want to remove this milli, so we would say that this is equal to 850, sorry, I missed a 5 here, 500 times 10 to the power minus 3 liters. So this is what milli means. Okay, now we want to convert it to centiliters. Okay, so to convert it to centiliters, I want to write it as 85500 times 10 to the power minus 1 times 10 to the power minus 2 liters. So now this is what a centiliter is. Okay, so I can say that this is a centiliter, and we multiply this with 10 to the power minus 1, we get 855 centiliters. Okay, it's not very clear, so this is a 5 and this is also a 5. It is 8550 centiliters. Okay, so this is fairly obvious how we convert one unit to another. Again, you have to be mindful of whatever you are doing. Okay, so let's move on. Okay, let me just remove everything that I have written. Okay, let's go back. So these are some example problems that you guys can solve. I would let me solve just one of this for you. So let's solve this one. Okay, so we want to convert 4723 micrograms to kilograms. Okay, so the way to solve it, again like previously we were doing, so we have 4723, we have 4723, and then this is micrograms, so 10 to the power minus 6 grams. Okay, and now we want to convert into, this is exactly what that means, and so to convert it into kilograms, I want to write it as 4723 10 to the power minus 6 times 10 to the power 3 divided by 10 to the power 3. Okay, grams. So I just multiplied this number with 10 to the power 3 and divided this number by 10 to the power 3, and so now this thing becomes, so this thing now becomes a kilogram. Okay, so we get 4723, and then we get 10 to the power of minus 9 kilograms. Okay, so this is the correct answer, but if you want to write it into scientific notation, we can also write it as 4 point, this has to be a point, 4.723 10 to the power of minus 6 kilogram. Okay, so you see how we can just to reiterate, you start off by writing whatever this prefix is in terms of a power, and then you want to convert this prefix into the prefix that you are looking for, and then you just simplify the result and you get the answer. I think it's pretty straightforward. Hopefully all of you guys would be on the same page at this point. Okay, so let's move on. So I would recommend that you try at least 2 or 3 of them, whichever you like, and try to see if you get the correct answer. Okay. And again, so now the other a bit more difficult thing is when you want to convert units which are products in themselves. So if you want to convert square meters into square kilometers, or you want to convert square centimeters into square decameters. So now we are not just dealing with centimeters per se, we are dealing with square centimeters. Okay. So let's do, I'll solve one example to help you understand how this is done, so then you guys can solve the rest on your own. So let's see, you have 56 square meters, which is m meter squared. Okay. So I want to convert into kilometers. Okay. So this is equal to, I can write it as 56, and what do I want here? I want 10 to the power of 3 squared meters, because 10 to the power 3 is 1 kilo, and because we want to convert into square kilometers, so the kilo part is also squared, which means that I need a 10 to the power 3 squared here. Okay. So if we multiply by something, we have to divide by the same thing, so to the power 2. So this then becomes 56 times 10 to the power of minus 6 kilometer squared. Okay, and this is our answer. You can write it like that. Okay. So you understand the process. If any time you have a product of any number, any quantity, you have to understand that the prefix itself is also a product. Okay. So if you have square, then the prefix is also squared. If you have a cube, the prefix itself would also be a cube. Okay. I hope I made my point fairly clear in this slide. Okay, so let's see the answer itself. So the solution, as I did. So you want to convert one, so you have 2 kilometers. To make a square kilometer, you need 2 kilometers. Okay, and then you get to this, and this is the answer. This is the same, I wrote it as 56 times 10 to the power minus 6. You can say it's just minus 6. Okay, so either way is fine. You can choose whichever you like, and just you can just stick to it. Okay. So now I want to convert 2 kilometer per hour to meters per second. Okay, so again I'll solve it for you guys. So we have, okay, I don't need a line, I need this. So we have 2 kilometers per hour, and we want to convert it into meters per second. So first of all, I can write my kilometers as 10 to the power 3 meters, and then 1 hour is equal to 1 times 60 times 60 seconds. Okay, so this is equal to 2 times 10 to the power 3 divided by 3600 meters per second. Okay, and then if you simplify this whole thing, you get whatever you get. I 2 divided by 3.6 meters per second. Okay, so I'm assuming that this part you can just do on your own. You can divide 2 by this number. Okay, so now we want to convert it into feet per second. Okay, so this is the answer for the first part, but now I want to convert it into feet per second. So 1 meter, so we know that 1 meter is equal to 3.28 feet. Okay, So I want to convert meter to feet, so I just multiply by 3.28 divided by 3.6 feet per per second. It had to be per second. Okay, let's get the pencil. Second. Okay, so I hope you guys understand what the process is, and you will solve more examples inshallah in your assignments and quizzes. Okay, so moving on. So this is the same process that we did. You can just check that whatever I did is the same as whatever was done in the book. So this is another example from the book. So we would discuss it in the Q&A time, but you can just go ahead, see the book and try to solve it on your own. If you have any queries, you can bring it to the question and answer session, inshallah. This is another example. This involves products of prefixes. So the question says that evaluate each of the following three significant figures and express each answer in SI units. So let me just solve one of them. So let's solve this 200 kilonewtons. Okay, so the SI unit is Newton, so we have a kilo here. So I want to write it as, let's just pick the pencil, and so I want to write it as 200 kilonewton squared. So which just basically means that this is 40000, then kilo is 10 to the power 3, and then squared means that you have another square here, and then you get Newton, and this is equal to 4, and you want to write it into three significant figures. So three significant figures is, because this is the first significant figure, this is the second, this is the third, it wouldn't matter either way. So I can just say 4.00 10 to the power of, so this is 6, 7, 8, 9, 10, 10 to the power 10 Newton. Okay, so again you can look it up in the book and try to solve the other two parts on your own, and you can come back to me if you face any problem. Okay, moving on. Again, we want to evaluate this number to three significant figures and express the answer into SI units. So now we have a quantity which has three different quantities which are products. Okay, so we have a product of a millimeter with a kilogram divided by Newton. So first of all, we want to convert this millimeter into meters, and this is already into kilograms and this is already into newtons. Then we can solve, and it is pretty straightforward. Hopefully you guys would understand if you look at the solutions of these examples in the book. Okay, so next thing, this portion is not the part of the book, but I have still added it. There are a couple of reasons for this, because first of all, I got this understanding that most of you are not very comfortable with volumes, so I wanted to add this extra part. So first of all, a volume is a volume is only applicable to three-dimensional objects. We cannot talk about volume of a circle, or we cannot talk about a volume of a line. Volume is only applicable to three-dimensional figures. For example, a prism, or a cone, or a cylinder, or a pyramid, or a cuboid, or a sphere. So that's the first thing. All of these are three-dimensional objects. The second thing to know about volumes is that a volume should always have the dimensions of length to the cubed. So the dimensions of a volume, okay, let's go back. So we know that the volume, okay, this has to be a V. So dimensions of the volume have to be equal to L cubed. Okay. So for example, if we look at the volume of a prism, it should have 3 length elements. So we have a base, a height, and a length. So this is the first length element, the second length element, and the third length element. So we get 3 length elements. Similarly, for a sphere, or sorry, for a cylinder, we have, these are 2 length elements, and this is the third. So whichever 3-dimensional shape it is, whenever we are calculating volume, the volume should have 3 length elements into it. So that's the first check that you want to always maintain. And these are some of the standard shapes. You might already know the volumes of all of them. If you don't, now you do. And one thing, any shape which is symmetrical in one axis, for example, this prism is symmetrical in this z axis, you can say. If I were to draw an axis here, so this is my x, this is my y, and this is z. So the shape is not changing in the z axis. So anytime you have this situation, you can just find the area of this base, and then you can multiply it with the length, and that would be your volume. So for example, volume of a prism is just the area of the triangle times the length. So area of the triangle is half times base times height, and then you multiply by the length, and then you get the volume. Similarly, for a cylinder, the volume is just the area of a circle. This is the circle, and then you multiply with the length, which is height. So you get pi r squared h. So this is a standard trick that you want to use. Okay. Okay. So let's move on. So the other quantity related to shapes is the area. So again, area can only be calculated for 2-dimensional objects. You cannot calculate the area. You can calculate the surface area, but area is always, it's a property of 2-dimensional objects. So for example, a trapezium or a rhombus or a circle, these are all 2-dimensional objects. But you can have, for 3-dimensional objects, you can have the surface area. So the surface area is the area of the surface of the 3-dimensional object. So for example, I'll just explain one of them, and you can just go through all of them on your own. So for a cylinder, if you want to calculate the surface area comes from 3 parts. First is the top, and the bottom, and then the sides. Okay. So the top has the area of pi r squared, and the bottom has the area of pi r squared, because both of these are circles. So you get 2 times pi r squared, and the middle is just 2 pi r h. 2 pi r is the circumference, and you multiply with the height, and you get the area on the side. So that's the total surface area. Okay. So you can just this is something that you guys needed some reminding, so I just thought I would add it as part of the chapter number 1. Okay. So this is it for the first week. So we would have, in the regular timings, we would solve some more examples, we would have some question and answer sessions, and at the end of it all we would have some quiz related to everything that we have learned. I hope I was clear enough for all of you to understand. Assalamu alaikum, and I will see you inshallah in the next lecture.